I was my friend.
Everybody there? When is the next Twitch live stream? Oh, okay. Did I? Oh, there we go. It's already started. Let me refresh the page real quick. I hope everybody is there right now. I just had to restart the stream. So welcome to Hello Network Lesson 2. I hope everybody is listening and fired up. And we're going to continue. So, a quick disclaimer, if you notice anything wrong with the learning material or if there are any errors, please feel free to leave a comment. Thank you all, and please enjoy the lesson. And share this with other people, please. I really like to help educate as many people as possible. I'm also gonna drop the link real quick. Let me drop the link real quick so people can see the presentation and follow along. The presentation link is gonna be in the Discord. I will post it right now. Let me see. Homework. I posted the presentation there, so if you need to copy any commands, you can just follow the lesson. We're going to continue now. Let me get the next step. Okay, let's go. Oh wait, I've got to share my screen right now. There you go. Welcome everybody to the stream. Can everybody hear me correctly?
Yes.
Okay, let's continue then. The next slide. So the topics we're going to cover right now are basic routing, command line interface, some talk about servers, and basic Cisco security. Yeah, those are the 3 topics I want to talk about. That's actually 4 topics with the subtopic. Let's continue. So we already previously talked about about routing itself, and it's still important to know that at least static routing makes use of different hops, and these hops generally are written in a routing table. We will cover that soon. It's also important to remember there are different routing protocols. Today we will only focus on static routing. So there won't be any dynamic routing or any other protocols, just static routing. So as I said before, in this section we're going giving a deep nose dive into basic routing, and before we can understand what's going on, it's important to learn how to calculate in binary. So that's basically what everything in the internet space is made up of ones and zeros, basically. So we're gonna start with subnetting. Yeah, let's get on that. So we already talked about in the last lesson that an IPv4 version 4 address consists of 32 bits. And 32 bits would look like something like this. So 8 zeros, 8 zeros, 8 zeros, 8 zeros. So every time you go to the next zero, you go from 2, 4, 8, 16, 128, eventually. So 2 to the power of 8. Let me give an example, as you can see here. So how would an address of 192.168.1.7.1 look like? So if we look at the way it's laid out, 128 plus 64 is 192. Then there's all zeros, so we don't have to do anything with that. From there we have 1 0 1 0 1 0 0 0, which is together is 168. And if you want to make 178, you have 1 0 1 1 0 0 1 0. That together that makes 178. And if we just want 1, we just have a 1 right here.
Yeah.
If you have any questions, please put them in text form, but I will answer them at the end of this subject.
No, not kind of.
Okay. So one thing it's important to remember is that a network IP address usually has two different spaces. It has a network ID and host ID. Your network ID basically displays the network you're in right now, and the host ID is basically how many hosts you eventually can have in your subnet. So down here you see the subnet 255.255.255.0. That means all of this space is network ID. To the right you see host ID, which is like in this case it is 1. Since it only goes up to 255, or I actually say 254, we can only have 254 computers in this network with this subnet. If we look at this one, that is a different one, 172.16.0.1, you can see that we have a different subnet. So that means we have more computers in the network, but we can have less of those networks because we have less network ID space. I put some actual learning resources if you're having trouble understanding this. There are some great resources down here. These are in the slides that I have put in the homework section. Let's continue with the next subject. Okay, what's also important to know is that there are different ranges, and these different ranges are defined in the RFC 1918. Sorry. Basically, this describes which addresses you can privately use within your network. So you have the 10.0.0.0 to 10.255.255.255/8. This is a subnet. Remember, guys, the slash means the CIDR. It's basically the subnet. So it's 255.0.0.0. Then you have the 172.16.0.0, 172.3.1.255.255.255, one with a segment of 12 or a CDR of 12. So if you calculate that real quick, 8 is 255. And then if you look to the next of that, okay, 12, we need 2 plus 4 plus 8. Now we have 6 plus 8, 14. We should have like 30 something, but you can calculate this. We're gonna go into that a little bit deeper soon. And now we have this slash 16, which is basically 255, And this is like the most common network. The 168 and then 178 or 168 is definitely very common. Yeah, that's what I wanted to talk about for the RFC 1919. Very important to remember. Then we're going to talk about the different classes that are assigned. So we have class A, which you can see here, which is the 255.0.0.0/8. The number of networks 125, the number of hosts 16,700,214. Then we got the B class from 128 to 191, 255.255.0.0/16. This is the subnet, remember, 255.255. And from there you can see we have a lot more networks, but our number of hosts basically decreased significantly because we have less. As I showed before, we have less host IDs available. And then class C, which is the most common for you guys, is 255.255.0/24, which has a lot of networks, but only 254 hosts. And like as I mentioned, when you do the math and count everything up, you get to 256 instead of 254. And that's because the first IP address and the broadcast ID from within the network are basically reserved, so you cannot use those. Any questions on this? So far? No questions? Okay, then we continue. There are also special IP ranges. These special IP ranges are for special purposes. So we have the 0.0.0/8, which is used to communicate with the local network. We have the 127, also called the loopback address, and the 169.255.0.0/16, which is the linked local address. So basically, when you have your computer and there is no server that gives DHCP out, you usually get this address, so all the computers can still communicate over the network. To understand the cabling, you first have to know how does a router, like which ports does a router have. As you can see here, we have a real life picture of all the different ports that are available. So these are serial cables, or serial ports, I'm sorry. And we got a console port, we got an auxiliary port, and like this is like an example. It's important that you remember how these ports look like, because you will definitely see them. And then the associated cables for connecting routers that are like 3 different cables we usually use, and those are serial cables like this one. We got the fiber optics. They usually look like this. And we got the RJ45 or network cable, and that looks like this. So to get into our example, I made a small lab for you guys so you can practice static routing. So yes, let's get into that, guys. So for any questions, or if you have any questions, just feel free to ask, because no questions are stupid here, basically. Yeah, this is Packettracer. Wait, did I miss any important information? Did I get a raid? Thank you for the raid, Gore7. I really appreciate it. I just noticed that you raided me. Okay, let's continue. Okay, I will continue with the lesson, guys. Because there are a lot of new people I want to join in, I highly recommend joining my Discord, because it does have the learning material you need to finish this assignment. So if you join into that Discord, you can just get the Packettracer. Does everyone have the Packettracer? Yeah, just let me know in the chat if you have the Packettracer open. So we go to the Packettracer. Let's save this one real quick. This one, you just open it with Packettracer. And after you opened it, it will look something like this. Okay. Now you have opened the Packettracer. You're basically first going to take a look on the network. So we're going to check, okay, what's this machine? Oh, it has an IP address, 192.168.1.17.82. What about this one? 192.168.180.2. And this one, what about this one? 180.182.2. Okay. So we know what the IP ranges are in our networks. From there, we are going to configure our static routing. And there are multiple ways to do that. For example, if I was on the device, I would need, for example, like my laptop, we get network cable. Wait, maybe let me get that serial. I think it's this one. Console port. There we go. We connect it like that. And from there, we are going to desktop. We're going to the terminal. Press OK. And now you see we have connected to this router. Because the interfaces are down on both sides, we are not able to connect to this router. So we need a special serial cable. We covered this in lesson 1. So we're connected right now. And look, the first command we're going to enter, of course, is enable. From here, you can go to the configuration page, basically, config T for terminal. With tab, you can autocomplete. From here, we can do a lot of things. We can configure the different interfaces. So if we go to our first interface, as we can see here, that's the gigabit 00. So we do interface gig 00. You can see we went into that interface. And if we type no shutdown, you can see our interface goes up. It becomes green. Very important to remember. But what if we want to send IP address to this interface? How do we do that? Good question. And it's a very simple command. You type in IP address, then you type in your IP. In this case, we need 192.168.178. That one? Is it too small, guys? Can you guys read it? Just want to know, guys. Can you guys read what's on the screen? Otherwise, I need to zoom in a little. Okay, I will continue then. IP address, we do the 192 IP address 192.168.7.1, and we type in the subnet mask. Since we use a CDR of 24, we're going 205.205.205.0, and there we set our IP address. And if we go into the configuration, we can see it's been set. This is like the manual way of setting an IP address for an interface. That's how you would do it from the CLI, command line interface. Okay? Everybody with me? Zoom in. Okay, I will zoom in. Hold on. How's the called again? Use magnifier. Windows plus. There we go. As you can see, we typed in enable, then config t, terminal, interface GI 0/0, no shutdown, IP address 192.168.1.7.255.255.250, and we typed in exit. Okay? From there, you also want to configure the other interface. So we go back one bit, exit, and we do interface serial /0/0/3, and we do exactly the same, no shutdown. You can also use the help command, I believe, the question command, and it gives you all the options basically. If you don't know a command, it's no problem. You can just find it here if you need it. Oh, we get out of this real quick. There we go. I wish I could make this bigger, but okay. Oh, your clock. Okay, let's get back in again. So we have to set the clock ratio to 96, I believe. I have to check real quick with my notes. Where's my mouse? What the? Oh, that's my mouse. Let me get my presentation again. We're gonna skip this real quick. Yeah, clock rate. That was the command, 9600. My bad, guys. Clock rate 9600. Zoom in again. Is it not the right command? Let me check real quick. Oh, it's with a space, guys. I'm sorry. There we go. We set the clock rate to 9600, and then we do IP address 192.168 179.1. Did I do it again? Cool. IP address. Oh yeah, you have to enter the subnet. I'm sorry guys. Almost forgot. 255.255.250. There we go. And we have no shutdown. And after you've done that, and you did it to the right interface. Oh yeah, okay. After you've done that, you see nothing turns on yet. That's because we didn't turn on router 1 or R1. So we're gonna do exactly the same on this router. So we're gonna keep this open this one, go to the CLI. Yeah, this is like the easy way, but usually you would do it from a computer. But for easy purposes, we're just gonna use the CLI at this point. So we log in, enable config t. Then we're gonna do interface gi 00. Then we do IP address 192.168.1. Okay. Oh, my bad. IP. Got the space, of course, and the. It's a tedious process, guys. That's the real networking stuff. For the 0. 255.0. Okay, there we go. So we configured this interface now, and we're gonna do no shutdown, and that brings our interface up. There we go. It's green. From there, we are going to get this interface up. So we do exit, interface, serial 0/3. Let me just check it. Did I? So I'm gonna check if I did the. Alright, there we go. This is the right interface. Now we do basically the same thing as we had on the other one, but we give it a different IP address. So we do clock raid 9600. From there we do the IP address 192.168.179, sorry, dot 2 instead of 1, because 1 is already taken with the other one, and we do 255.255.0. There we go, and shut down. And as you can see, after we did this, the interface gets green. You see that, guys? We got an established connection from router 0 to router 1. And if you go out of Zoom and we press P on our keyboard and send a package to it, you can see down here it says successful. We managed to send a packet from router 1 to router 0 to router 1 and back. Because ping is always two ways. It's going and it's going back. Any questions so far on this? Any questions, Wada? Oh, awesome, awesome. Let's continue, guys. I'm excited. So let's do the same thing with this R. Let's continue on the R1 because we still have to do the other one. So we basically do XZ one more time. Let's get in zoom again. There we go. And we do this command. Now we basically do the same thing, but then we have to be careful that we set the IP to 181.1. We set the same clock rate. From there, we do no shutdown. Okay. And then you will see nothing because we still need to configure this one. So we go to R2 and we do basically the same commands. Config T is for short, easy way. Interface, I believe that's SE031. Just to check. Yeah, okay, it's 31. No shutdown. We're in that interface now. No shutdown. And you will see this link also gets green. Okay. From there, we're also going to set the clock rate. So clock rate 9600. Exit. Then we're going to configure this interface, the gigabit interface to interface GI 0.0/0. No shutdown. IP address. IP. Doesn't that work? Hold on. That's why. And then set it to 192.168.181.2 with the setup mask. Boom, right there. And as you can see, all our interfaces here have an IP address, all of them. Let me just check if I did only right interface. So if you go into here, you can see that I entered the wrong IP address. My bad. Has to be one. Yeah. You have to do the serial one still. My bad. So interface serial. Didn't it already configured? Okay, because it's already set. Okay. And then we do IP address 192.168.181.2. Let the setup mask go first. There we go. Okay. Let's see what we can do right now. Let's get out of this stupid mode. From here, we just removed our connection, but it's fine. You can see down here, we can ping to other routers without the hop. But what if we try to do this from R0 to R2? It gives a failed. So what we need to do for each router, we need to configure a static route. So one of the easiest ways to do that is do in the CLI. Question mark. As you can see, you can see other commands here. The easiest way is probably just using the configure right here, but you can also do it with the CLI. For each of these, we just use this tool right now, but you will see the equivalent command show up down here. So we want to go R0. This is all in the spreadsheet, guys. Like if you go into here, into the presentation, if you are not there yet, it basically shows all the commands you need to enter. So let's do that right now. So we go to static and we type in 192.168. You want to go to this network basically. So we type in 180.0. We add the signal mask. We're gonna add this hop, so this side, and as we can see right here on serial 00, you can see it's 2. So we're gonna add that to our static routing table. With this command IP route, you're gonna configure terminal. You can add a static route using the CLI. This is using the GUI. Now we do exactly the same on this side, but the other way around. So we do 192.168.0. That's the network we want to reach. We type in the setup mask, and now we type this interface. So that's 192.168.178 dot 179. I'm sorry. 179.1. There we go. Let's see if we can ping between these two sides. Let's see if it works. We try to put a ping. Let's delete it first. A ping between PC0 and PC2, and you see it failed. But how is that possible, guys? We just saw we have added those routes to our routers, so they should be going. And then, has anybody any idea why this is not working? Why can I not ping PC0 to PC2? Anyone any ideas? Nobody any ideas? Come on, guys. You already talked about this. You know it, Swada? Okay, I'm gonna help you guys. Since we don't have a default gateway configured in our PC0, we have to configure that first. So we type 192.168.2.178.1. That's this interface on this side. And we do exactly the same on this side. 192.168.180.1. Okay, let's see if we can ping. See? That's still not working. Oh, there it is. There it is. Successful. And as you can see, if we do simulation, Let's do simulation mode. And we do the simulation. You can see our package is actually going over there. And this is because we have these default gateways configured correctly to reach out to the gateway, the router. And we have the routers communicating with each other from here to there, to there, to there. So it knows the entire route where to go. It's for the task for you guys to figure out, okay, but what if I want to go to this network? How do I do that? That's for you guys to figure out. And if you have managed to finish this assignment, you can send it to me on Discord so I can check it. But it shouldn't be too difficult for you guys. I already showed that this is working, and the things you have to add is not that much. Okay, let's continue with the next subject, or the next thing. Let me add the PowerPoint back in. So we have done all this configuration basically. That showed. So what I want to talk about now, let's go back before we're gonna finish this subject, is the time to live, the TTL. It's basically prevents network packets moving indefinitely over the network. It can be done for networks, but also for DNS. For DNS, it's primarily how quick the domain name server has to update its registry. That's one thing I still want to cover. Yeah, this is the configuration, guys. Okay, let's talk about servers, guys. So there are a lot of different kind of servers. You have web servers, DHCP servers, mail servers, VPN servers, DNS servers, NTP servers. So it's just important to remember that all these services can be installed on one server. So yeah, that's one of the things that's important to remember. So that's not they're not all separate servers. They could be like dual role or triple role servers. As you can see here, this is an example of a blade server, or like a rack server. That's what I meant. Sorry. And you can see like a regular server. About operating systems, obviously they use Windows Server or Unix, but they provide the same services. So for the networking guys, it doesn't really matter. One thing to remember about TTL is for Linux, it's 64, and for Windows, it's 128. That's one of the ways you can actually determine easily what kind of system you're dealing with. And here's another picture how things should be plugged in, basically, and how it looks from the back. So just for this demo, we are going to deploy a DHCP server on our network. There are two ways to do that. You can do it on a Cisco router, or you can deploy a separate server that does this. For this lesson, we're just going to deploy a separate server. Okay, let's do that, guys. Let's go to real-time mode, and we're going to get a server. There we go. We connect it like this. And we got our server. From here, you go into services, and you go to DHCP. You configure your network, so default gateway 192.168.178.1. They type it in here. 178 dot 1. Maybe the 2. Maybe that's a little bit better. 255.250. Save. 255. Save. And turn the servers on. Okay. Let's see if our PC0 gets an IP address on DHCP. No, you see it gets an IP address. Does anyone know, since we have configured DHCP on the server, why this PC0 doesn't get a valid DHCP IPv4 address? Does anyone know? Anyone knows why our PC doesn't get this IP address from the DHCP server? Anyone? Come on, guys. Okay, I will help you guys a little bit more. It's because our server doesn't have an assigned IP address. Go into the configuration into fast internet, you'll see an IPv4 address is not assigned. So if we assign one real quick to, I don't know, it doesn't really matter what you put in there, but like 50 or something, there we go. And we try this again. You'll see our PC0 actually gets a DHCP IP address right now. That's because the server was not able to communicate on layer 3 with all these devices, or at least this PC at least. So if we check this one, we come to this one, and we do exactly the same. You see, it gets an IP address assigned again. Okay, so let's see how that DHCP assigning looks on the simulation scale. Well, let's auto. There we go. As you can see right here, you got the STP packages from the routers, but I believe if we put this into here we go. So if you set it to DHCP, it basically will ask on the network, okay, I want to have a DHCP single or a DHCP IP address, and it will basically ask anyone on the network. And this case, because server 0 is a DHCP server, it will respond with, hey, here I am, here's your IP address. And from there, it will go from the server back to the PC0, and it will be assigned. So we speed this up a bit up. I think it's already assigned, isn't it? Let's see. You can see all the DHCP requests that have been made. You can look into one package. There we go. Oh, it opened. No, it did. There we go. Here you can see how the package looks like basically if you press one down. yeah, source MAC, source IP. Like this is all this is the whole package basically. Yeah, very important that you know how this protocol DHCP works because it helps you to troubleshoot the network. Okay, let's go to our last session, last topic. Yeah, that's basically how to do it. Yeah, this is demo. So the last topic I'm going to talk about is basic security on Cisco devices. It's not only routers, it's also switches. Yeah, so let's have a look at that. So basically, when you let's go back to the Cisco Packettracer. Go into real-time mode. If you go into your Cisco router, normally when you get into it, you don't have a password. Basically, anyone can sign in and change your router settings or your switch settings. And that's not what you want. So to prevent anything like that happening, you go to enable and you type in the following command. Config T enable secret password Cisco. And why do I give secret? That's because it allows us to encrypt or hash our password, so people cannot see it. I will give a demonstration of this maybe. So if you just did a regular enable password Cisco, and we would do exit show run configuration, show run config, and you go all the way down. You can see the running configuration, but you can also see it should be there. Let me check real quick what's going on. Alright, now it gives a password. So Cisco, there we go. Not sure why it wasn't. There we go. Enable password Cisco. And usually this is a very bad idea because anyone that has physical access could maybe recover the configuration file and just find the password. So to prevent that from happening, we use the secret command. So we do the same as we did before, basically. Secret or enable secret password Cisco. There we go. And then if we do the same thing again, you see our secret is actually encrypted. So if people get hold of our configuration file, they are not able to steal it basically because it's encrypted. Just because we did it like this, you can find it as still Cisco, but you guys get the idea. let's look at some others, because it's basically all the same. But there are multiple ways to get into the Cisco switch. So you have the cable, as we mentioned before, like this. We got over the network, and we also just got the CLI. So if you're directly attached to the unit, and to also block those, you basically need to configure them separately with passwords. So let's try that now. Um, so you enable config T line console 0, and we do login password secret Cisco. There you go. Exit. So if we attach our console cable again, I hope it doesn't crash again. Bro. I'm sorry guys, not sure what's going on. Let me reopen Packettracer real quick. It's basically frozen. Yeah, let me boot up the Packettracer real quick. My task manager is not responding. Oh my god. Oh, there we go. End task. Here we go. We open it again. There we go. We attach our computer real quick. Connect it to our console port. Get into the machine, desktop. We go to terminal. Okay. Enable config T. Then we enter those commands again. Line console 0, login, password secret Cisco. Type exit. Basically just get out there. We basically start the connection again. If you saved it. Oh, I'm not sure if you typed in login. Let me check. Oh, that's for the virtual terminal. Hold on, guys. I believe it is correct. Okay, there we go. Now you see user access verification. So now we type Cisco. There we go. Cisco. Let me just reboot the thing because it's fucked up. Real quick, guys. I'm sorry. It's rebooting the machine because apparently I typed the password wrong. Not sure what's going on. Yeah, we're almost finished, guys. Don't worry. This is normally the configuration menu, but we don't want to do anything with this. There we go. It's gonna be global. Okay. Exit. Line console 0. Login. Password. Secret. Cisco. Exit. Cisco. I'm not sure why this. What the? Do we need to? Maybe just a little bit confused, guys. Why it's not working? No. Let's see if let's just do it like this, guys. Let's see if that works. Team terminal. Okay. Oh, there we go. Just use the password without secret, and add it in my PowerPoint slide. Then you have a password, basically. Very simple. Yeah, we can do the same for the VTI 04. So we do config T line VTI 04 login. Oh. 04 login. Okay. Password Cisco. Now we type in exit. And after the last thing, we're going to go back to config and type in service 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 password encryption. Okay, I'm gonna do exit show running config. And as you will see, all the way down here, our passwords are encrypted, so that nobody can steal them. to save your configuration, you basically type in copy running config startup config. Okay, the last thing we're gonna add before finalizing this lesson is to add a banner. So you can do banner config to banner mot hello world, or we do not have access, or something, I don't know, just making something up. And then if we go to exit, there you go, hello, you did not have access. So if you want to make a personal message, you could put that in there. Okay, this was the final slide basically. Yeah, does anyone have any questions so I could answer? Any questions? No? Swena, any questions? No? No questions? Okay. Well, for us, an assignment is to finish the Packettracer that's in the homework folder. If you have finished it, you can send it to me so we can check it. Yeah. Good luck, guys. The next stream will be next Friday, the same time, 8 p.m. in the evening, Amsterdam time. Thank you all for watching, and I hope to see you in the next stream.